Inverse trig functions. You can only find the inverse of a one-to-one function, and these angles are measured in radians. So sine x, there you can see not a one-to-one, so you have to define it with a domain and range to make it a one-to-one. So you can see I've taken a section where sine is a one-to-one, and you can see I've written down my domain. That's your x values and my range. It's like the y values, but we use f of x. To find the inverse, you literally swap the coordinates around. So swap the x and the y coordinates. So you can see that's the graph of your inverse, and the domain of your inverse is the same as the range of your function, and the range of your inverse is the same as the domain of the function. Cos x. So there's your cos x graph, not a one-to-one. Define it to make it a one-to-one. Looks like that. X lies between pi and 0. Range again between 1 and -1. Then to sketch the graph, you are swapping your coordinates around, and you can see that your domain is now the same as your range, and your range of your inverse is what the domain was. So pi minus 1 becomes -1 pi. The last and more complicated one is tan x. So not a one-to-one, you define it to be a one-to-one. You can see your domain lies between pi by 2 but cannot equal them, and your range lies between infinity and -infinity, but of course cannot equal them. So when you sketch your inverse, you're going to have horizontal asymptotes at pi by 2 and minus pi by 2, and so your domain lies between infinity and -infinity, and your range lies between pi by 2 and -pi by 2, but cannot equal them.